Hi there, Arthur here. In this month's Release Note video, Rosario mentioned that you can now stream the response of callable functions. And I thought it would be interesting to take a closer look at what this actually means. Before we get ahead of ourselves, you might be wondering, what are callable functions anyway? Callable functions are HTTP endpoints that run inside of a Cloud Run environment. This is similar to if you wrote an HTTP request handler using Express.js. The key difference is that when writing a callable function, you use the Firebase Functions SDK and its onCall method instead of Express.js's HTTP verb-specific methods. Firebase's onCall method has a couple of neat tricks up its sleeve. For example, it automatically passes and validates authentication tokens and app check tokens. It also automatically deserializes request body and makes it available to your function. Finally, you can specify runtime options such as the amount of memory and the number of CPUs you want to make available to your function. So instead of configuring them in the Cloud Console, you can declare them in your code like this. Once your callable function is deployed, you can call it from your mobile or web clients. Once the function finishes its work, it will return the result to the caller, in this case, your mobile or web app. As you can see, callable functions are a great way to share functionality between your apps. However, your callable function might need to perform some heavy lifting or fetch a lot of data from a database. So while your callable function is busy, to the user, it might seem that nothing is happening. And while you can show a progress spinner to your user, it sure would be better to progressively reveal the result of the backend computation. And this is where streaming callables come in. You get all the same benefits of callable functions, but with the added ability to stream the results back to the user as they become available. Let's take a deeper dive into how we can implement this in our own apps. Let's say, for instance, that we are creating a photo processing app where it segments the people from the background. It then changes the background to grayscale and it writes the image to a storage bucket and returns the image to the user. We're making our own color pop filter. Now, we could provide the final output to the user once it's ready, but let's update the user as we make progress computing our color pop image. Here, you can see that we start with the normal callable signature, a request and a response. Then, as we add steps to our code, we can check whether the request accepts streaming, and if so, send chunks back to the client. The client can receive these chunks and update the UI to reflect the new state. As you may have noticed, we make a lot of calls to request.acceptStreaming, and you may be wondering why we did this. The acceptStreaming call checks if the client making the request wants the response to be streamed. This is helpful if you haven't updated all of your clients to support streaming. If the call confirms the request accepts streaming, you can proceed to stream the results. You can then add streaming support to your clients, one by one or all at once, whichever is best for you. For your client-side code, it should be very familiar. You set up the callable function as normal, but you then call .stream on the callable function to initiate a streaming request to the function. Then, we can use streamAsyncIterable to update the UI every time a new chunk is sent from the function. We can also await the data promise to get the end result when the function is done. There are many more use cases for streaming callables that we didn't get a chance to go over today, such as aggregating multiple data sources or streaming results from a GenKit flow. Check out the documentation linked in the description below. I'm Arthur Thompson, streaming to you from YouTube.